Hey, I am Rob, Rust Station Rob on GitHub. So I just want to give a little background because I don't think very many people know me. I studied math. I guess that's contextually um, why that's important is in theoretical math, you're always kind of, I think, looking for something to do with it. Like, okay, I'm learning this shit, but what can I actually do? So one summer, I was just going through YouTube and I found this MIT OpenCourseWare um, discussion on Bitcoin. It was a course on Bitcoin taught by Taj Drija, the creator of the Lightning Network, so to speak, or at least the author of the paper. And of course, he very eloquently laid out how Bitcoin works. And ever since, I was very interested in the technical side. But then when I went to actually use the software uh, on my little MacBook Air, I realized that my resource requirements were far too low. So then I eventually came across Lalu talk at SF BitDevs. This is another YouTube talk, and he got me really inspired by this vision for the future where your phone is a Bitcoin node, your router is a Bitcoin node, and they're all paying each other Lightning. And I was like, okay, what's the status of that? And basically, there's Neutrino and not much else. So that's kind of what inspired me to write yet another compact block filter light client. And so that's what I'm going to talk about today. So as a refresher, because this is a pretty dense protocol in terms of technicality, on a high level, block filters are just a way for a light client to query should they be interested in a Bitcoin block without actually downloading the entire block, because blocks can be up to 4 MB, and in practice these filters are only like a few hundred bytes in memory, and they can be represented even more compactly over the wire with a cool technique called Ghulam coded sets. So Ghulam code is in a binary representation of some number. If you expect it to have a lot of zeros, you can instead say there's 7 zeros inbound, or 70 zeros, or whatever it is. You just say the number of zeros, and then followed by the number of ones. And by doing so, you more compactly represent instead of a byte for each zero. So these filters and, of course, the blocks themselves, they're served by full archival nodes directly over the Bitcoin peer-to-peer network. So I think when I talk to other wallet devs, they're often confused because it goes against the typical HTTPS model where some server is doing something for you. These are actually directly accessible only by the Bitcoin peer-to-peer network. So in essence, anything that follows this protocol, it's implied that they have to implement some sort of subset of the Bitcoin peer-to-peer messages. And then they also have to maintain a list of potential peers and find new ones in a way that is Sybil resistant or Eclipse resistant. So this presents challenges in its own right. So you normally just find peers by connecting to somebody and asking like, hey, who do you know? And another method is with DNS, which I actually like quite a bit, but comes with its own trade-offs. And it also implies that you have to kind of have a notion of the chain of most work, or else somebody could just give you block headers that make complete nonsense. Like they pass their own proof of work, but the work target is just nonsense. So you actually have to follow that bit of consensus and say, are you giving me headers that are computing the difficulty adjustment correctly? So while that sounds relatively trivial in Rust, of course it's a pain in the ass because there's no 256-bit integer representation in Rust. So then you're left with making your own hand-rolled big integer math to just compute this stupid number. So I'll get into that kind of later. But also, yeah, so once this client says, okay, I found a match with the compact block filter. Now I need the block. Then it just sends it on to the wallet implementation. So in this case, I'm offloading all of that to the bitcoindev kit, which I think is a really cool project, because once I find the block, I don't have to do anything else. I just give it to whatever wallet software is in the background. So that's the refresher of how this model works. And so, like, why is this interesting? Well, the light client user is protected by the you get what I mean, the privacy set of the entire block they're downloading. This could become a potential issue if you're just getting all of the same blocks from one peer, because then they can take the intersection of scripts in those blocks and be like, okay, you're probably this guy. So in practice, you want to open multiple connections and then download the blocks at random from these people. Or even deterministically, which is a patch I might do next, where to make sure you never create like an intersection between two block requests, you can just connect them in like a deterministic order. So that's cool because in the current state, if you want to use a mobile wallet or something like that, you're basically just saying, hey, here's all of my addresses, here's all of the Bitcoin I might own, now tell me how much Bitcoin I have. So for like chain analysis, that's of course like a wet dream, but for like an average user, that's not very good. So also there are many potential peers that the client may connect to. So for the same reason that you don't want to just like fork over all of your addresses to some random person, you also don't want to just like constantly be broadcasting your transactions to a single person as well. And so this model completely breaks that, where you can just connect. If you were at the demonstration on the main stage, you can just connect randomly to a peer, broadcast your transaction, and be done with it. And that's exactly what this implementation does. So in that sense, it's more private as well. New features of the peer-to-peer network are more easily integrated into a compact block filter node, because you don't have to wait for some like server company, whatever, to patch their implementation to support what you need. Like let's say package relay or something like that. That's going to become important for time-sensitive protocols. You don't have to wait for Blockstream or whatever to update their endpoint. And I think actually we're seeing that some of these like Explora-based projects are becoming somewhat deprecated. So there's no like API compatibility risk there. And then yeah, so the whole point of this as well is that it can run on very constrained platforms, mobile, desktop, or even like a low-cost VPS. I think that would be really cool. I've looked it up, like how much would $1 a month get you, and it should give you enough RAM and storage to be able to run this protocol and host your wallet there. And I'm hoping to eventually get support for LDK node, and so you can run kind of a routing node for yourself for just like $1 a month. Okay, and then a demo break, because I want to just demonstrate what it looks like in practice, because I think it's pretty cool and it can make for some cool user experiences. So this is the Bitcoin Dev Kit example iOS wallet, and it's going to be running one of these compact block filter nodes in the background. And we should watch it sync up to the chain from like last night when I was testing this. So yeah, we're not connected to anybody at the moment. And I'm going to try and resist the urge to just like check the logs and see what's going on. Experience it like as a user myself. Okay, boom. And so it was able to sync from the day before. And I sent myself some fake sats here. And so this is like my dream of what this might look like. You're basically logging on to your wallet and syncing from like the last day of work Bitcoin blocks. And yeah, just like a quick little tour of the wallet, because I think it's cool. You can get some testnet sats, or we could like scan and send to ourselves. And I wanted to start with the mobile demo because one of the challenges with compact block filters is to check the filters, you need to compute a bunch of hashes. And so this can be quite heavy for your phone to do. And that's why I think when Neutrino was first integrated into Zeus or something like that, people were like, dude, this is like nuking my phone. What's going on? And it's because it's doing a bunch of hashes that are not CPU optimized. But thankfully, since then, the mobile OSs have gotten really good about being able to register background tasks and stuff like that. So what I'm imagining a wallet dev would do, and probably what I'll submit as a patch once this integration is complete, is that when your phone is plugged in the middle of the night or whatever at like 3 a.m. and you're not really expecting any payments, your wallet can still catch you up with the rest of the chain, like while it's has resources and it's connected to Wi-Fi. And then this way, when you go and want to pay for something at the bar, you're at least partially synced, like to the last day or like the last week. So that's where I see this model actually reaching feature parity with like Electrum or something like that. Is you need to just be occasionally pulling the chain in the background, even if you're not really expecting payments. You still need to just scan and be sure. So this can happen like while the user is asleep or something like that. Yeah, so I'm hoping, so this, if you find this app interesting, it's going to be only available on test networks, but it will be available on the App Store pretty soon. And I'll have a link to the GitHub project. The maintainer is Matthew. He's a really cool guy. And so this is what it might look like on mobile. And if you'll humor me, I will also show you what I vibe coded a couple weeks ago. This is the desktop version of the very same app, and this is what I would imagine and probably what I'll release and use myself as the desktop version of a compact block filter based client. So it actually opens as an app on my desktop. So here's what it looks like. It's very simple, very hard to mess up. You can open the settings and do, connect over a Tor proxy if you want to do that, or determine the number of like node connections you have. And so we'll start. I do have this sum wallet here, which is actually a descriptor for like a big faucet, so that's why it has a bajillion transactions. But yeah, we'll go ahead and import a wallet. And so right now, just because this is the extent of the vibe coding I wanted to do, I have it parsing 3 types of file formats. We have the cold card, which is actually just the same as the generic text file. You just put your descriptor in a text file. And then also Bitcoin core format. So I'll go ahead and import one of these Bitcoin core JSON format descriptors. And if you've ever imported JSON into Bitcoin core, you know how much of a pain this process is, putting everything in like backticks and shit. So I wanted to make sure like you have a JSON file, you just import the file. So we're going to do that. We're going to name the wallet, I guess, demo. And then we will watch it sync. So I have this notification like, hey, this is probably going to take a while because you're scanning since SegWit activation. Do you have any scripts? So again, once we get to the next kind of the challenges and solutions portion, I'll talk about what I have in mind for that. But yeah, for now, the best you can do is just scan every single block and see, do I have any coins in here? And that's how you recover your wallet. So I guess we can look at the logs and see if it's doing things properly. Okay, it's trying. Attempting to find peers on Signet is quite a challenge because there's about like 4 of these that serve compact block filters. So okay, now we're moving along, so we can watch our little progress bar go. Yeah. So up until this point, does anyone have any questions about the protocol, how things work? Because then I'll get into the more meta discussion. All good? Okay. Actually, I'll go off of Do Not Disturb because this was my favorite feature of the AI added was like a little notification thing. So while we're getting the presentation, we should get a notification that the wallet syncs. So hoping the demo gods work with me there. But okay, so that's all the good. It works. You can build wallets on it. Yeah. What's like the reality check? What's the downsides? There's a few. So developer and friend of mine, Nick Johnson, he developed this cool program that essentially took a census of Bitcoin nodes by first starting with DNS and then listening to gossip and trying to compile a list of potential Bitcoin nodes. And of the 11,000 or so listening nodes he was able to connect to, this is over ClearNet, so this is why this is so like skewed low. Most of the listening nodes will be over Tor. Around 10% of them served compact block filters, which isn't bad, but like the vast majority of the time, when you hear a peer gossip to you, they're not going to be listening for incoming connections. So even further still, if you make a successful connection, only about 10% of those are going to actually do what you want. So that serves as a problem, and we just saw right there. I had to like go to the logs to see like, are you actually doing anything? Because otherwise, it's just like trying to find peers. So as a caveat, this should get better for ClearNet in the next release of Bitcoin Core. After many years, finally, when you run Bitcoin Core out of the box, it opens ports and listens for connections. So up until then, this was not the case. I think really early on, there was a patch that was like super vulnerable that like enabled this by default, but then like it was like a nightmare and was like since taken out. So this is great news for compact block filter clients. And all you have to do, I guess, is update your node if you're already running the index. And so, but back to the reality here, the sync times are basically determined by how fast can you churn through your database and find somebody to connect to. So, like, again, it's not horrible, but that's the main challenge that we're facing when we want to use a protocol like this. And of course, there's ways to get around it. You could just use DNS every time, but then you're relying that the DNS seeder isn't serving you some like Bitcoin cache node or some shit. So yeah, if you're curious about this census, I think it's really cool. He has graphs and stuff. He runs it on his personal blog. If you want to get an idea of like what type of features and stuff that the ClearNet nodes are running. Okay, yeah. So into the slew of challenges, fee estimation is just not really possible. Given just the information of a block, you can't compute individual transaction fee rates. This is because you would need the input data corresponding to an out point, which is not present. You can do one trick, which I've implemented. You can get the average fee rate for a block by taking the total Coinbase output minus whatever the block subsidy is, and then you divide by the block weight, and that gives you like the average. But the average is pretty horrible in terms of estimation purposes, because as it currently stands, it vastly overestimates the fee required, because there's like a few people that are like paying a shit ton of money to get their ordinal in or something, and then everybody else is just paying normal like 1 sat per vbyte. So these numbers are like particularly skewed at the moment. But I can demonstrate that. I guess once we're done syncing, I can show like what that flow looks like in the desktop app. Another thing, these compact block filters, they can't be audited because again, you don't have the out points. And when you construct a compact block filter, you're doing it strictly from the script pub keys that are involved in this transaction. So they're not present in the out points. And so if two people lie to you or disagree, you can't figure out which one is like bullshitting me, because there's no way to retrieve the script pub key for the corresponding out point. And that's not, again, with everything, it's not like entirely true. You can do so if the transaction was in like the last couple blocks or something. There's some sort of like Bitcoin Core policy where you could fetch that from a peer, but like in practice, it's pointless and not usable. And okay, so the last big one, I think a lot of people, including myself, are excited about silent payments. But a huge problem here is that you again require this input data. same old problem. You don't have the out points. You don't know the script pub keys. You can't compute the shared secret to then compute what potential outputs you might have for your silent payments scanning. So all of these rely on the out points, which brings me to my next slide, because they all have the same issue and they can all be resolved with the same solution, and that's the quote-unquote undo data. And the reason it's called undo data, it's basically the collection of all of the inputs corresponding to the out points in a block. And the reason we care about this, and it's called undo data, is when a block gets reorged, you use those corresponding inputs to undo the block and replay those inputs back into the UTXO set. Of course, if they're not present in the new block. So you take the intersection and you find which ones are not included in this new block. And then you leave the rest in the UTXO set. So Bitcoin Core is already storing this locally as an index. And so serving this over the wire would enable basically the following. It would enable a protocol like native silent payments light client, which I find really fascinating, because as it currently stands, you have essentially a server behind some sort of endpoint that serves you the shared secrets that you might need if you want to scan for silent payments outputs. And this relies very heavily on just server altruism. Like, this person could get bored running the server, not want to pay the costs, and just stop serving them. This would allow light clients to at least audit that the filter was constructed correctly. So if we get to a point where there's a bunch of malicious clients that are just constructing bad filters, you can easily determine like who's bullshitting me with this data. And then it would enable more robust fee estimation. So this would be transaction level estimates. You don't have to do this like Coinbase trick. And by doing so, you can remove outliers of like, okay, this person paid exorbitantly high, or this person paid particularly low and probably paid a minor out of band to get their transaction in. And then the last thing, and what I'm currently kind of working on, is it would enable a fully validating SwiftSync node / client. And we can talk about SwiftSync later if you don't know what that is. But of course, this would require some sort of new commitment scheme. And it kind of is just a chicken and the egg problem, where it doesn't really solve fundamentally this. We can't audit the filters, but it gives us a lot more usable data to do a lot of things that a light client might want to do. In particular, in the Lightning context, it's basically, without some sort of mempool.space endpoint or something, it's basically unusable, because you can't accurately determine a fee with your channel partner. I mean, you can sort of by throwing a lightweight statistical model at like the block average fee rates or something like that. But it starts to get really complicated, and this would just make it a protocol native way to remove outliers from your fee estimation. Okay, and then the other improvements are, basically we've been waiting for this thing to sync. Oh, okay, yeah, and I have one transaction. So the notification service didn't quite work. I was hoping to see this guy. Do you see this little check your wallet for updates? I was hoping to see that while I was giving the presentation, and it would be super cool, but that's not how the demo gods work. We just saw like that was a decently long recovery time just for Signet. So the current filters, they're quite wire efficient. Like, getting them off of the internet is very fast and bandwidth efficient, but they're not CPU efficient at all. One block results in each hash having its unique keys, and then it also uses SIP hash, which is not CPU optimized in any way on any modern mobile OS. So you're basically doing this inefficient hashing function, and you have no way of determining what it might look like for the next block until actually getting the block hash. So in that sense, it's very, 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 very CPU intensive. So in my research and potential future improvements, one way to easily improve this is like, I know I'm recovering a wallet, and I want to do a sort of binary search and query a large range of blocks and then like this larger filter would perhaps be like about the size of a block or something like that, because presumably you're going to be downloading those anyway. So let's say you download this kind of like mega filter for like 10,000 blocks or like 100,000 blocks or something. And then you check with one hash, am I included in any of the 100,000 blocks? And so you've reduced your hashes by a log scale down from, n blocks down to one hash. So that wouldn't nuke your phone, and wouldn't require you to like put it on the charger when you just want to sync your Bitcoin wallet. And we could also use CPU accelerated hashes. Again, the OSs are always improving their APIs and stuff. So I'm sure we have access like, hey, can you please do this SHA-256 very fast on your dedicated silicon, whatever it is, Android, Apple. Please do this hash in a faster way, because SIP hash is not frequently included in CPU accelerated hardware. So some work in reducing the altruism, because basically everything that I've talked about relies on people like you just like running this index and then listening for connections to light clients. Again, the first thing was just by nature of the patch, ClearNet nodes will be listening for connections in the next Bitcoin core release. So many people may be just like ironically running this index and just serving it to nobody, which I think would be kind of funny. But yeah, we'll see if those numbers change. I'm actually curious over the next coming years if like this upticks based on the simple fact that people just thought they were listening for connections and they weren't. An index can make rescans faster. So if you're like finding yourself constantly, with a new hardware wallet setup, or you have a Lightning node that you're routing on top of, and you're finding yourself rescanning, then like running this index will make it much faster. So I'm constantly trying to find use cases for using the block filter index outside of just being nice. So that's one of them. It'll make your rescans much faster. And then there's ongoing work in just making the index building much faster. So like when you're doing IBD, you have to be computing this index. It can be yet another sidecar thing that makes IBD slower. So there is work to make this process move a bit faster, and that would be quite nice. And then yeah, this is pretty much towards the end. I want to talk about my new, or not my new, but I have joined a new company called 2140, and we're in Amsterdam. And so I just wanted to give a brief like shout out as to what it is. I think of it, and I think most of us there think of it as like a kind of developer collective. Like I don't have any projects that I'm like forced to work on or something like that. I sort of pick what I like, and then you're surrounded by people that can help you and rubber duck ideas and stuff like that. And so we have people from all over, LDK, Lightning Labs, me doing on-chain stuff, Bitcoin Core contributors. And so it's a really nice place to just like, if you have an idea, just rubber duck it off of a bunch of experienced devs. So what I'm working on, this light client, which is pretty much in maintenance mode. I'm happy with all the features. So I'm just shilling it out to people, letting people know it exists, and trying to build more private light clients on in mobile or otherwise constrained devices. What you can do, I mean, there's a bunch of stuff. If you're interested, come by, just shoot me an email and see if you want to come by the office. If you're in the EU, pitch me a topic or something, and maybe we can have like a week about it, like a cashew week or like a lightning week or something like that. Because I almost guarantee you'll come away with some new information that's just not going to come through on GitHub and pull requests and stuff like that. And as far as light clients, what you could do, you can just run peer block index equals 1, and I think block filters index equals 1. And in the next Bitcoin core release, that's all you got to do, and then I'll be able to connect to you. And And yeah, so that's my email, rob@2140. I'm Rustation Rob on GitHub, and I have an RSS feed that I have like one one blog, but I'm hoping to like up my blogging skills. So yeah, that's how you can contact. And here's a whole bunch of resources. I didn't really get too much into the technical side of like the future research for querying filters, but um, that would be here. So if you are like a math nerd, I recommend this paper, which I was reading just from Sci-Hub. But yeah, so it's the ability to test multiple sets at once with multiple members. Hey, does any one of these sets contain one of these members? And again, it's doing so in a way that's hash efficient and CPU efficient. So that's like where we could work towards in future research. And as foundational stuff, I think they're pronounced cuckoo, but I call them cuckoo because I can't really bring myself to call them cuckoo. But so cuckoo filters, they're again a different type of compact sketch, like multi membership query set, which would be sort of the foundation to this like multi-membership query. So you have multiple blocks with equally sized cuckoo filters. And then also there are quotient filters, which is a different type of compact sketch, which would again enable the same thing. We have equally sized quotient filters, and we're just efficiently querying all the blocks for inclusions. Development, it's all BTK related stuff. My repository is held at 2140-dev. It's called Kyoto. There's like a cookbook example in the book of BTK, and then there's also mobile bindings if you wanted to like test around and get something started. Apps, the desktop one is under my personal. You can make an app. I hope you do. If you get bored, vibe code something. And then here are all of the kind of things leading up to this that I described, the MIT OpenCourseWare, SF BitDevs. These are really cool talks, and I think it shows just how like sticky a good idea can be. Because like, I mean, Lalu was talking about this in like, I don't know, 2017, 2018, something like that. So very cool if you want to hear the initial motivation that he had for Lightning Labs to implement this, the census data, and then finally the BIPs if you're like nerdy enough to read it. Yeah, I think that's pretty much it. So I was going to, just as a final little demonstration, show what it looks like to, yeah, this is what it looks like to receive a payment on this app. So you just copy it or something. And then to send a payment, let's just do like a coin consolidation. I don't know how many, that many sats. And here's where this last block average fee rate comes in. So as you can see, 13 sats per vbyte is completely ridiculous for Signet. Somebody's just making some humongously large transaction set at like 3 sats per vbyte, and then it would save a PSPT. Oh, okay, operation not committed because I have it super sandboxed. But yeah, that's about it. Thanks guys for listening. I have plenty of time for questions if anyone wants to pick my brain on anything. Go. So one of the core dependencies is called Tokyo, which is the async runtime. And Kyoto is a small city near Tokyo. So and the desktop app is called Amstel, which is a river very close to where I live. So I just like look at something, like that's the app. Yeah. Okay, cool. Thanks, guys.